Okay, so there's François online, and also we have Rebecca from University of Talinn. Hi, Rebecca. Nuno. Do you want to say a few words?
Yeah, I'm associate professor at Talinn University, former Londoner, so it's great to be back.
Okay. Thank you. And Phoenix, just say hello to make sure we've got the lines.
Hey,
Right.
I'm Dr. Phoenix Perry. I'm a reader here at the University of Arts, London. My research involves machine learning, small data sets, and embodiment. And you guys have me, Tom? Okay, I'm going to stop talking.
Okay. Okay, great. So we're all online, and we're going to start with a few prompts to the panelists, and then we'll open it up to questions in the room and also online through Hackspace's YouTube channel, right, JB? Yeah. Okay. So the aim of this panel is really to discuss some of the things that we were talking about this morning. So thinking about current practices and challenges of using small data sets of music with AI models. And thinking especially about responsible AI and ethical AI challenges in that area. So I'm going to ask each of the panelists to just briefly introduce themselves again, but also talk about their current practice using AI and small data sets, and the challenges that they find, and also maybe what they think is unique about the kind of data sets that you are using. So I'm going to start with Rebecca.
All right. So hi, I'm Rebecca Fiebrink. I've been working with music and AI for nearly 20 years now. A lot of the work that I'm currently doing has really come from a stream that I started around 2007, 2008, which wasn't focused on music generation at all, but was really focused on asking and exploring the question of, what can AI and machine learning offer that's useful to musicians. And at that point, I was working with mainly electronic experimental musicians and people who were interested in building new musical instruments. So someone who said, hey, I've got some sensors and I want to use those to get information about how a performer is moving on stage. Or I want to use audio signals from an acoustic performer or video signals and understand what people are doing. And I want to use that to inform how a digital musical instrument makes sound, right? How are those synthesis parameters controlled, for instance, in real time? And so that was really what I focused on in my PhD work. I made a piece of software called Wekinator, which uses very straightforward, simple machine learning on small data sets in an interactive context. And this came up in Gabriel's talk, really, in the first case study we heard from this morning. The idea being that somebody could give some examples of, hey, I want to move like this, and when I do that, I want the sound to sound like this. And you can have 5 examples, 10 examples, maybe a couple hundred, but you don't need a lot of examples if you have a reasonably good sort of feature representation from those sensors, and you have an appropriate machine learning model. Something like a shallow neural network with one hidden layer does absolutely fine at these kinds of simple problems with small data sets. And through that process, I think I really changed the way that I thought about machine learning, even though I have a computer science background and came to machine learning with sort of a really traditional textbook understanding of how you do it and what it's for. That work really changed the way I think about data sets. So for one thing, a textbook approach to machine learning, you're thinking about a data set as some kind of ground truth, and you want to model that ground truth as accurately as possible because that, phenomena that are maybe hidden in that data is something that you don't completely understand as a person, and you need the model to make accurate predictions, or you need a model to represent that data. But actually, in a lot of the musical contexts I was working with, and then later on in other contexts, including people designing games and work that I've done with Phoenix, people do understand their goals for the model. They might understand them very deeply, but still struggle to communicate that to a computer through language of, computer programming or through mathematical representations. If you say, I want to move like this, the natural way to communicate that is by giving examples of motion. Or if you say, I want of data sets in many musical contexts, as data sets are a way for people to communicate with machines, to communicate what's in scope, to communicate their desires for a machine. So in that sense, a small data set that somebody has created or curated with a lot of focus and time and intention can be much more useful than a generic data set that you don't really understand, that doesn't necessarily capture the things that you care about. Another perspective really that came out of my early work that I've been weaving into my later work is thinking about data sets as I guess, interactive machine learning with small data sets as a mechanism to explore design spaces and to not just communicate your intention in a moment, but actually co-develop with a machine some kind of system that represents your creative goals, right? So it's, if we think about design processes in any domain, including composing music or improvising music, often you might start with an idea, you might build a prototype of that idea, or you might play it on an instrument and try it out, and your own thinking and your own ideas are informed by that experience. And then you say, okay, well, now I know how that went, let me try something slightly different. And if you have a small data set and you have a machine learning system that can train really quickly and produce a model very quickly on that small data set, then you're able to give people these interactive, iterative loops of saying, okay, I'm going to try this. What happens? Okay, well, now I can change the intention I'm communicating by changing the training data, see what happens again, and iterate on this. So this interactive machine learning process can be a really fruitful way for people to discover, okay, what's possible, and how do I work with this computer system to get to something that meets my goals. So I'll leave it there for now.
Thank you. And hand over to François Pachet online.
Yes, so I'm, yes, like Rebecca, I've been working in this music and AI for a very long time. I don't want to know. I've been working in particular for 20 years with at Sony CSL in Paris, where I've developed a number of AI technologies to do mostly music generation, audio, but audio and symbolic, but mostly symbolic. That is, at the score level. And then I continued doing this at Spotify for 6 years, and then I left Spotify recently. And so we indeed, when you send this mail about the small data sets, actually, I did not even realize that was really a key topic. In fact, I think everything we've done that was interesting was always with not only small data sets, but even sometimes like singletons, like data sets with one tune. So for instance, we launched this thing called That Is Car, which is a pastiche of a Beatles song, whose score was generated from a model trained with 44 Beatles songs. So 44 is small, I guess, by today's standards. Then we launched this album called Hello World, where lots of songs in there were generated in many different ways. But I'm thinking about one of them, who is called Sensitive, which I think is very good. As it's a pop song inspired by the style of Tom Jobim, like bossa novas. But in particular, it's very much inspired by one song called Insensatez, which is a very well-known song, and which tries to use or exploit some kinds of harmonic tricks that Jobim has been doing in that song, without doing any plagiarism, just trying to do something different with the same ideas. And it's also like a one song experiment. I mean, technically it was not one song, because you always need some kind of word model to do all kinds of lower level inference. But really, the most interesting experiments we had at that time was with one or like small data sets. And then at Spotify, we worked with a company called Soundtrap, which was acquired by Spotify at that time, which is a kind of GarageBand online. So it's purely like online music editor. So we could work with lots of users at that time, and it's kind of obvious that when you have an AI model trained on hundreds of thousands of songs, no one knows what it means. No one knows what they can expect from that. And it's a natural tendency for users, for musicians, to think about like being inspired by one song or two songs or three or maybe 10, but not like hundreds or thousands, because it does not mean anything to them. And so, for instance, there we developed something called rhythm transfer, which was, I think, pretty cool. And the idea was to take one song and another song and create a third song by taking the harmony of the first and the rhythm of the second. And that would create like some kind of rhythm or harmonic transfers, as we call them, which were really very, very interesting. And I would say like 2 songs was already a lot because users had to choose them, and find compatible pairs and stuff like that. So I mean, yes, that's what we have been doing for a while. Now I've left this world of Spotify and all that, and I'm focusing on publishing. I mean, not publishing in the sense of labels, but my position, and I make it a little bit radical just for the sake of this workshop. But is that most of the work in AI today is focused on audio generation with incredible results, by the way, of course, as we know. And in fact, there is still very little in the domain of composition, in addressing the question of how to generate a nice melody, a nice song, with melody chords and stuff like this, basic rhythms. I've not seen anything really interesting yet, and I think that's unfortunate. But I think that this problem is actually much harder than the audio generation one, for some reasons that we can maybe talk about. And so that's what I'm focusing on now, trying to work at a strictly composition level without with very, very little audio. So that's what I'm doing now, and I don't know how much time you gave me and how much time I've used already.
This is perfect, yeah. So we gave you 5 minutes and you've used 5 minutes, so that's super.
Great.
Thank you very much, yeah. So Nuno?
So my background is actually in audiovisual composition. So I work not only with sound but also visuals. I've had a long practice of playing and performing with sound and visuals. And I would say for the last 10 years since I finished my PhD, I've been really interested in developing tools for audiovisual composition together with artists. And also another thing I've become quite interested in is embodied interaction, so exploring the body as an interaction modality tool. So working on that and working on that level took me to machine learning, because machine learning can really accelerate the process of collaboration with artists, of getting results quickly through their outputs, and also, of course, also accelerate the process and kind of give more expression to the process of embodied interaction. So the interaction, machine learning really accelerates and really augments the potential of embodied interaction. And for the past years as well, I've worked a lot in the field of contemporary dance. So how movement, especially movement of expert movers such as dancers, can generate audio, can generate imagery that connects to their own intentions of expression. So working with these dancers, with these choreographers, what kind of performance, what kind of experience do they want to convey? And then, very lately, we added one piece to this kind of construction, which is the audience themselves. So what do the audiences want of these experiences? Do they want to contribute also? And what do they want to contribute in terms of movement, in terms of sound, in terms of imagery? So this sounds a bit abstract. I can give a few examples of the performances we have worked with. So, for example, one of the latest pieces we've worked with is a performance installation where you go into a space, you move around in that space, your movement is captured, and then it is associated, your movement is matched with the previous closest movement, according to this algorithm, that has been performed in that space. And the movement your movement will produce sound, your movement will produce image, and then after you execute the movement, and this can be done by anyone, it's an open installation, you get an audiovisual outcome of that. Not only that of your movement, but also you get matched with the movement of a previous attendee of that installation. So yes, these are small data sets, especially in the beginning when we are training with the system, with audience data. Of course, this is collected with a consent. We can discuss more the ethical parameters of this, but this is collected within the scope of this experience. So it's a relatively small data set. So I'm very interested in some concepts such as model crafting that Abu Zuraik and Pasquier have mentioned. We're interested in concepts such as latent mappings that Murray Brown and Tigas talk about. So the idea of through the body, going through the latent space and how you connect these different dimensions. Also, we heard Gabriel earlier talking about these issues in his case study as well, which I think we can also interconnect. And so I'm very interested in these different aspects, these concepts, and also how to involve artists and audiences when there's audience participation, how to involve them and their intentions. So we can continue on this, but I think it sets the ground for what I do.
Thank you, Nuno. And Phoenix?
Hey everybody, I am Phoenix Ferry. I originally got into working with machine learning back in, I guess, like 2010 or 11. I was using a camera to track my own body movements. And at the time, I was an active performing audiovisual musician in a band with my collaborative partner, Margaret Shadell. And we had a project called Black Swan. And we were playing live, and I have a disability that really impacts my cervical spine and upper body. And I was just finding after our live shows, I was physically dying, and I couldn't do it anymore. I was like, I need to be able to do way more physical movement because my disability particularly thrives when I move around. Like, thrives is the wrong word, but I thrive. My disability doesn't run the show when I'm able to move around a lot. So I built a interface system for myself that let me move around a lot and not be hunched over computers. I'm also a games designer, so for me, making music and interactive 3D worlds felt automatically like a thing you should do. And my partner was working with a ton of sensors. She's a cello player, and she developed this thing called the K-bow with Keith McMillan that has just about every sensor you could cram on a violin bow. And we were using that, and then some interesting, fun other sensors depending on like what mood I was in. And it was an amalgamation of stuff. And I started using cameras and just trying to do camera tracking, but that only got me so far. And then I started looking into machine learning, and I started using this thing that was letting me do some interactive machine learning. And then not long after that, Meg met Rebecca at a conference, and she was like, we need to be using this much better thing. And so we started using Wekinator early on to take a lot of our data and track our music performance and my embodied interactions into creating and driving a three-dimensional game space for live performance. And that let us do some pretty tricky things back then that I didn't even realize would ever become a thing or that any of you here would ever care about. That was very bizarre to me to find out. But what that led me into thinking about was ways in which I was encountering performance, and it was a very different kind of way of interacting with making music or making audio visuals than being bent over a computer, right? I could have much more organic gestures and much more organic ways of moving around three-dimensional space. And that led me to really want to release my record, but I realized I could not, because you cannot release a 3D audio visual world that involves that many different tools that are all hodgepodge together into some sort of amalgamation of a performance environment. And that led to us only really ever being able to show the Black Swan stuff live. And years later, when Rebecca and I were talking, it occurred to us both that we could roll all that up and put it inside of a game engine. So we released an interactive machine learning tool called InteractML for Unity, doesn't really work in Unity anymore, gave up on Unity, never developed for Unity. He's an open source developer, it's a nightmare. But Unreal is really stable, and our Unreal version is amazing. And it had over 60,000 users last I looked 7 or 8 months ago. So it's been a really successful tool that is allowing a lot of game designers to explore gesture and interaction in things like VR and in things like, you know, embodied movement. We have had students of ours use it in their own live performances, and I don't think I've ever been so emotionally overwhelmed as when I got to see someone perform with tools that had come out of my own performance practice. I recommend it for any musician or artist in the room. You'll sob like a child. And that was, I think I've got 30 seconds left. And anyway, yeah, small data, awesome. I love it. Been working with it for over a decade. You know, no data is neutral. All tells a story. I'm out. I'm 19 seconds left.
Thanks, Phoenix. Perfect. Yeah, that's great. Thank you very much. So we have an introduction from the panelists. We have a few questions that we're going to prompt them with, but also think of your own questions. We have time for the audience to ask questions directly to panelists, and also online there'll be some questions as well. So I will kick off thinking about, so you were all talking about using data sets, and it all sounds like you were using, working with your own data sets actually, and that's where the data sets come from, rather than going off and finding other ones. So thinking about how you use those data sets that you yourself has created, like what are the main challenges with doing that? Why is it difficult to create your own data sets or use them? What do you find problematic? I'll start with Rebecca first, and then we'll go along.
Sure. So I'm going to answer this at a little bit of a higher level, because mainly the serious work that I do isn't, you know, performing myself with my software. I do that, but that's kind of a side project. But I'm thinking about supporting people who are using my software, who are, you know, making musical experiences, performances, et cetera, with their own data sets. And I think, you know, one of the obvious challenges is just computational, right? If you have a very small data set, there are some things that are going to be possible to learn and others that won't be, and that depends a lot on the representation of that data. And so actually Louis, who's here, worked with me ages ago as a postdoc on a project where we were experimenting with saying, how can we perhaps help people understand better representations of the features that might allow the kind of, you know, learning the kinds of concepts that are of importance to them. And that's, you know, still a very, very difficult kind of challenge. Gabriel, who spoke earlier, has done some really fantastic work with a system he built called RVAE that he uses in performance, and that is, you know, using symbolic musical data to train on, and it's generating symbolic music data for the simple fact that that's a lot easier to build a model that captures the patterns in something like MIDI than audio waveforms. So that's, you know, an easy to identify computational challenge, but I think it's wrapped into interactive challenges, which is that when you have someone who, you know, comes with a sort of musical goal, which might or might not be well defined, what I want to do as a software developer is support them to navigate this really complicated design space and say, well, if I use this representation and this data, what could I do with it? And if I use this model, what could I do with it? And then probably iteratively explore that, which is super hard even for people who have like computer science degrees, and it's even more hard for people who come without a deep understanding of machine learning. So some of my work is also around, you know, what do people who might be practitioners working with small data sets, working with machine learning creatively, what do they need to know about machine learning to navigate these challenges more effectively?
Yeah, okay, that's it. Super interesting. So maybe, François, in terms of the question of selecting the machine learning models, you know, and how you do that, maybe you could talk a little bit to that. So the challenges you find with using the small data sets, but also responding a little bit to what Rebecca was saying there about the challenges of actually knowing which machine learning model is going to be the most appropriate for what kinds of data.
Yeah. So first of all, I have always worked with illegal data sets. That's very but I mean that's very important. I built a huge database in Sony called LSDB with 15,000 lead sheets, all illegal, or at least let's say borderline, in the sense that the legal status of this is really unclear, especially in Europe. It's less unclear in the States and Israel, for instance, but in Europe it's really unclear, and it has not improved since. And then when I went to Spotify, I rebuilt the same database, and now I'm rebuilding it for the third time. No, that's important because there is no, and I'm talking about publishing, symbolic music in symbolic form here. I'm not talking about audio, but as you know, in audio, it's also pretty illegal to build a database of audio waveform. I mean, as long as the music is copyrighted. It's not illegal, but it's complicated. That's the first thing. Then obviously, it's interesting in the conversation we are having, it seems that everybody is taking for granted that obviously you are going to build an AI model from this data set. I mean, I think the workshop is about data set. I'm not sure exactly the term, but it seems that everyone, of course, thinks that you're going to build an AI model, probably with a transformer or something like that. And that's probably going to be the case very often, but it's not necessary. And I don't think it's the road for the future. I mean, I don't think it's enough. So the scheme is always a bit the same. The idea is that you build a model using a huge data set, or maybe you reuse an existing model that has been done previously, and then you try to fine tune it on a smaller data set to kind of get what you want. I have never seen this working well in my life. I've never seen this working, although on paper it works very well. I think it works quite well with text, actually. And you can see it actually, there are lots of tools online, but for music, I've never seen this working. So what do I mean by that is that if you take a small data set, again, I'm sorry, I'm going to take illegal stuff just because it's easier to communicate between us. Because if I talk about music that no one knows, it does not make any sense, right? But if I take a composer who has done, I don't know, 10 or 50 or 100 songs, and try to build a system that's going to create scores in that style, well, I've not seen anything working. So it means that the idea that the state of the art in the technology we have now is I think fine tuning. I mean, maybe people disagree on that, but fine tuning in the sense of reworking an existing model trained on a huge data set and then reworking it in some ways to fit with a very smaller data set. I've not seen this working for scores. So what we do well, we do all sorts of stuff. We try out other ideas. But what I want to stress, maybe as an example, so as a musician, for instance, it's very frequent that I work for a very, very long time, sometimes for 1 year, on like one song. So just as an example, currently I've been working on this song called Summer Soft by Stevie Wonder. It's not very new. I think it was done in the 70s. But the harmony is incredible. And I'm really surprised. So first of all, you have lots of stuff on the web, people trying to explain what it is, how it works, why it's so great. And it seems so. Maybe infinite is a bit excessive, but it's so huge, the amount of knowledge you can learn as a human. I'm talking now, right? As a human, just by working on a single tune sometimes. And when I do this, each time I play it, each time I go through all the tricks of this thing, I'm amazed at how smart it is, and I'm thinking, what how come that all the fine tuning we do are not amazed by what we give them? It's like they just follow it. So there is something wrong somewhere, right? Because as a human, I don't see the end of what I can learn for one song. And then when you do fine tuning, it's just like 1 or 2 passes of statistics which are being updated. You know this very well. And so I think that one interesting question is go back to what we do as musicians, maybe, when we are amazed by one song and you studied for years. And I'm not the only one. I mean, many musicians do this, especially in jazz, but in pop as well, and probably in any other genre. But so what is this ability that we have as humans to dig into a song endlessly, endlessly? I still continue to listen to the Pink Floyd, and I'm still amazed by, there is still something I don't quite understand in there, right? And so obviously we don't have the models currently in AI that are able to do that. That is to dig into at several levels of depth, until you say, okay, I have enough. I think I got it. I think I've completely swallowed this thing, and it's part of me now, and I can proceed and do something else, right? And so I think that my 2 cents is currently what we do with small data sets is fine tuning, and correct me if I'm wrong. And it's very far for what we as humans do when we fine tune on even one song. That's all I can say. I mean, and I'm sorry, Rebecca, I'm not answering your points, but
No worries.
Yeah, that's great.
but that's the mood I am in
Yeah.
currently. It's like I'm amazed by my capacity to focus on one thing only, and it's not the current AI.
So, well, thanks for those points. I think that's super interesting. I wonder if Phoenix or Nuno have anything you want to respond to Francois' point?
I mean, that's just not the kind of work I do, so I don't have much to say about it.
So what are the challenges when you're using data sets in your kind of work?
Well, I'm aware we just passed over Nuno.
Oh, please.
We'll get back to Nuno later.
My challenges are so different. Like they're so different. I might start performing again. That's the new goal. I bought a new synthesizer. It's very exciting. After doing all the Black Swan shows, after the last one we did, I was getting like well too involved. There were like at least 100 candles. There were burlesque dancers. It was becoming a whole affair. So I decided to stop, and I've not performed in about 8 years. And I'm thinking about doing it again, which is really exciting. But my biggest problem was 1, lighting. Oh my God. 2, mirrors. 3, my data set not being big enough to capture the gesture that I needed to make in that specific environment. So like I might have thought I got my data set all sorted out, and like I thought this did a thing, and I'd get into a room and my camera would be ever so different and the lighting would be ever so different, and the background, and that would do nothing. So it wouldn't respond, and then we would respond in a weird way. It'd give me something really random. I'd be like, that wasn't what I was expecting. So like my problems have come from like performing with my own data sets. And also sometimes there are these weird, I don't even know how to describe it, particularly when we work with your own data, just like dips. Like things that like you really didn't expect were gonna happen. There's like gaps in it. You can kind of feel it. It's got this kind of like, you're like, oh crap. What do I do now? I guess I need to play something. So, my challenges are specific to kind of my own embodied interactions with it. It never even occurred to me to use anyone else's data. So like, that's why all the like new genre of Gen AI stuff, like it's fascinating to me because it felt so outside of any reason I was ever doing it in the first place. I was doing it to experience my body. I was doing it to experience a new way of making music, a new way of performing, a new way of feeling the creative process and being with the creative process. So like I like these new problems that people are having around legality, and this is like surprising to me. I'm a little green when it comes to it all, I gotta say.
Thanks, Steve. And Nuno? And maybe also talk a little bit about, you mentioned audience, right? And I think you're the first person that I've heard talk a lot about audience and the audience relationship to machine learning models and that kind of thing. So maybe touch on that a little bit.
True. So I'll start before the audience, and then I'll go before the audience comes in, and then I go to the audience part. So in terms of challenges, I was thinking I can summarize it as 3 challenges that we face specifically in this kind of co-design process with the artists to create this kind of a piece that involves machine learning for sound and or visuals in my case. But one is the challenge of collaboration and to understand what we want to do together as a collaboration. Sometimes we don't know ourselves what we want as a result, so that's always a kind of a search. But as this grows into a team with different aesthetic intentions, just to find that is tricky in any kind of technology-mediated process. But with AI, it adds, or machine learning, it adds even more trickiness due to the clunkiness of these pipelines. These pipelines are kind of clunky. This model crafting, which involves training sets, model architectures, and hyperparameters. It's a clunky universe to tweak. It's not like just changing a knob. It adds. There's a lot to dig in there. So yeah, these pipelines are clunky, and of course, as we move forward, they become more fluid and more flexible. But we're still not there yet. So that's one of the challenges. The other challenge, so the collaboration challenge and the clunkiness of the pipelines that we're dealing with. That we've come a long way, but still, iteration takes time. Then the third challenge is the one thing I hinted at in the beginning is because we're dealing with user-generated data. Users in the beginning are usually the artists themselves, and then the audience comes in. But we're in rehearsal stage. Usually it's the artists themselves providing this data. In the beginning, things are very tricky because there's a lot of overfitting. So there's not enough data to create novel results. They tend to glue themselves to the previous results. But somehow there's also something of interest, which is there's a lot of glitches and a lot of surprising results come in, and there's a lot of beauty in that the artists usually that we collaborate with don't want to polish out totally. And that's something that I've seen in some of your papers, Nick, actually coming out in terms of surprising results that come from these errors. About audience, this is something we are starting now. The new project I'm working on is the first one that we're bringing audience into the equation. So I don't have a lot of results to report on. We're actually writing now a paper about precisely about this. And we had an audience studies with questionnaires, interviews, these kind of things. But there's in this kind of experiences that we're designing, they're installations, but they're performative installations. So the audience, what we see is a lot of interplay. But this comes with a lot of technology-mediated installations. There's a lot of interplay between watching the audience as watching. The others perform, the other audience members perform and try to decode the system, and then they themselves trying to go in and decode the system. So I think this interplay is interesting, and especially the mechanics we've incorporated, which is reflexive. It compares their movement with other movements, also kind of stimulates that. So there's something there which is more universal, and some that has to do with the kind of dramaturgy of that piece.
It sounds like that connects a bit with what Phoenix was saying before, but also what Ricardo was saying in his earlier case study as well. Do you have extra points you want to make?
I think when the imperfections I mentioned, another thing that I think it's interesting here, and one of the beauties of working with our own data is the importance of process. So this pipeline in itself is the work to a certain extent, that we collect the data, we also kind of organizing that data. That's something that is clunky. So that's something that we would benefit. That's something we can probably discuss further in another round. But that's something we would need help with, organization of data and how to curate that better, because now it's quite manual still.
That process, though, is so interesting. Like that process of creativity, whether or not it's a machine learning system, a keyboard, or a guitar, is the creative process. And I feel like we're never going to emulate that specifically. We might get close with enough study and effort, but what makes that process special is that embodied knowing, which you just don't get any other way, because it's contextual, it's situational, it's what you ate that day, it's what you saw that day, it's the weather, it's the lighting, and that process of the experience is really how that stuff gets interesting and rich. And for me, that was the most exciting part of of thinking about this stuff was using it like a way to explore my own process of music and art making.
Great, thank you. So I'm going to move on to audience questions. If we have any questions from the audience. If you have a question, put your hand up. We have a roving microphone that will come.
It's there.
Oh, it's at the front.
Just toss
We
it.
can-
You can throw it
Can
at
we
the
throw
bottom.
we can
It's
throw it,
soft.
yeah. You can
So,
throw it. It is
wait,
soft.
there you go.
Almost.
The pillar was.
So there's a question. Please say your name, where you're from, and your brief question. And then we've got a couple of
Thank you.
questions online as well.
That's lovely. My name is Aldo. I'm from Italy, and I do musical improvisation in Baroque and so forth. And I was wondering, it's not very comfortable to all. I was wondering, you mentioned explicitly linking the intention of the performer to the result. And of course, Phoenix, you mentioned about cello, bow with a bunch of sense. Obviously, that's a tool that requires a lot to learn how to navigate, but it gives you so much resolution in terms of the stuff you can want to do, even in the actual instrument. But how do you go and link the intention of the performer to the result in your experience? I mean, it's actually a question for both.
I have some thoughts. I mean, I'm going to give you a really punk rock answer, which is the cello player is the person crafting the intent into the system themselves, right? So like when Meg was making music with her bow in our, my very small one bedroom in Brooklyn, she was hearing and seeing how that was changing the system. And we had whole visual responses. I think you saw some of them, like the particle system we hooked up to her bow. We had a particle system that was hooked to her bow that when she bowed really, really lightly stayed just kind of like a thin vibrating line. And then as she would begin to like really push down, it would excite the particles in the system and kind of spread them further apart, and the emitter would get,
She could experiment.
she could experiment with
Learn
it.
how to
So
talk
like,
with it.
exactly. So like I would come up with a visual thing that would kind of mirror what I was seeing as from her performance. She would sit there and play with it, then we'd riff on top of it, and she'd go, oh, maybe if it could do this, and and we would collaborate back and forth like that. And I think that anytime you have a human in the process of shifting and creative and recording what the model does to how it responds. So like Meg would play, we'd record it. Because Meg's heavy bowing is going to be different than someone else's heavy bowing. It's the angles of it are going to be different. The like way the sensors are going to give data, it's going to be totally different. It's going to be different if she's on a different cello, which was kind of interesting. We played, she has a couple different cellos because she's Meg. And, we would see different results based on whether or not she was playing her electric cello or her because it was giving a different response. And I think if the artist is the one building the intent into the system and using it improvisationally, as you suggest, that's how you get those really rich, dynamic, responsive, creative spaces.
So I've got a follow-on question from Andrew McPherson.
Oh,
who's
hey,
online.
Andrew.
Yeah, hi, Andrew.
Hey, Andrew.
Thank you for Bella.
So he has a preamble, but the core of his question is really, when you're working with artists or with your own creative practice maybe, how do you decide what matters or not before you even get to training the models? Before you even think about which model am I going to use or how am I going to train it, how do you actually work with people to think about what is going to be important there? So Phoenix just touched on it. Maybe Nuno or François, if you want to, or Rebecca, if you want to respond. Who would like to jump in? I'm looking at
Rebecca.
Yeah, I can.
Rebecca or Nuno, for sure, yeah.
I can quickly add something to it. I've made that process simpler by myself by adopting kind of a structure that facilitates suggestions from the artist. So, which is similar to what we're doing actually here with the Music RAI project, which is having a call, and then the artist sends their proposals, and then we select among these proposals some that feel fleshed out and going in the direction of the challenges we pose. And then it's really, we call it mentoring. It's kind of a mentoring process where the artist leads and we follow in a sense. Of course, there's always some push and pull. It's not always as linear as I'm kind of portraying it, but I believe it is like that. There's an aesthetic intention of the artist, and we try that we collaborate with, and we try to stay as close to that as possible. But of course, we inject our own suggestions inadvertently or more specifically, and that also becomes part of the art. So it is a collaboration in the end. It's a collaborative process. But we like to think, maybe we're idealists, that the artists lead it, and we kind of curate. There's an initial phase of curation, which comes from the structure, the rules of the game, which is a call and selecting the call. So there's a curation there, and then we mentor. Okay. So curation and mentoring, plus collaboration.
Yeah.
So that would,
I don't know, Rebecca or Finn?
Yeah, I mean, I think that's a really good description of the way that I look at it a lot of times as well. The one thing that I would add is back to what I mentioned about the education component of a lot of my work. You know, the more that you can think carefully about, you know, what would really benefit these artists or collaborators to know about machine learning and sort of the constraints that the algorithms themselves or the infrastructure is going to put on what they can do, then that, you know, gives them more agency over the process. And that's not an easy thing to do always, but I think it's very worth doing.
yeah, very good point.
Yeah, I remember the first time you were explaining some of the stuff that Akinator could do to me, or could do to me. That's funny. It did things to me. But I could do with it is that I sat there and I was like, wait, what? Wait, what? And it really was, I think I asked Rebecca to explain stuff to me at least 80 times. You were so patient.
Okay, thank you. And we've got a question here in the room.
Yes, thank you very much. My name's Hussein Boone. I'm from the University of Westminster. My question is primarily directed towards François, but then also might well branch out to everyone else. François, I'm going to paraphrase. You did an interview in the Jerusalem Times 2019 where you discussed a new kind of development that, in terms of thinking within Spotify, that would give producers unparalleled control, and I'm paraphrasing, to be able to manipulate the listener. So I'm just wondering, and given that what you were yes, I know. Because the thing is that the details were very sketchy, and I really would love to hear a little bit more about what you're talking about there, because obviously when you're talking about large data sets, Spotify's kind of library of music is a very large data set as well. And whether this would then mean, what this would mean in terms of musical labor. Would producers forever be trapped in a feedback loop of improvement for their songs rather than progressing forward? So that's the skinny. Thank you.
Yeah, no, thanks for the question. I mean, I don't speak Hebrew very well, so I don't know about the translation, but I know probably what I wanted to say. I think I was talking about the work we did on skip profile analysis, and which I think was fascinating and is still. And the idea was, when you play a song to people, the song that you have done, produced, composed, whatever, and then it's very interesting to know when people get bored, have enough. I'm talking here about mainstream music. I'm not talking about improvisation and other settings where, things are really different. Your mindset is different. Here I'm talking about pop music where every milliseconds, people stop listening simply because they are bored, and also because they know that they have millions of other songs to listen to, so that they don't really care, in fact. And so we did some work there. It's published, by the way, easy to find. It's published. There is a paper in PLOS, I think, PLOS One, where we found out that the way that people stop listening to a song is very counterintuitive, in the sense that for a given song, you have what we call the skip profile. That is the profile of people skipping across time from the beginning to the end of the song. And this profile is independent on space and time. That is, for a given song, you look at the profile one day, and then 3 months later, it's exactly the same. And you look at the profile in Europe and in the States, where obviously it's different people listening, it's also the same. And so it means that the way people skip to a song is a very robust kind of DNA of the song. And I think it's fascinating, not to listen, not to manipulate the listener. I don't know exactly where this comes from, but for a composer, a creator, to understand when people, get bored or skip, stop listening, so it does not mean that we are trying to build a song or songs so that no one skips. Actually, I showed in the paper it does not. It's meaningless because people skip when something happens. So the only way to have people not skipping is to have a song where nothing happens. And actually, this is exactly what happens. But then no one listens to it either. So there is a trade-off to have between popularity and skipping, if you want. And so yes, I thought we tried to understand why people were skipping, and the project was to try to verbalize. So for instance, you have a song, and you have a system that tells you, hey, here when the sax solo starts, it would be better if it was a guitar, or it would be better if it was longer or shorter, or if it comes before or after. That kind of decisions that you make when you do a song, right? You make a lot of decisions, and you are never completely sure if they are good or not. You know only at the end. So I was mentioning this most probably at that time, and yes, there are papers about that. It's really a fascinating subject, because I think music is the only domain where you can know, at least you can get this information, because you have these key profiles. You don't know how people read books. You don't know really how they watch movies. You don't know anything about other art forms, like in terms of how people, enjoy them or not, or don't. In music, you do have this information, and I think it's a fascinating area. And I'm sorry for the translation. I mean, the goal was not manipulating the listener. The goal was more understanding the effect of what you do on the audience beforehand.
I mean, if there was one thing, if I could just follow up, because when I think about test cases, when you think about, say, Leonard Cohen's Hallelujah, it wasn't particularly a hit. It took over a 20-year process and had to go through several kind of revisions and different kinds of performers and so on, and then becomes canonized into something else. So the question really is about the impact that data sets like this or data interpretations might have in terms of influencing how people actually do music, rather than actually understand that actually liking something might well be a cultural process that may take a long amount of time to go through.
I understand the question, and you're right. There is a kind of chicken and egg here, because if you start using tools that are based on what people do, obviously there is a bias somewhere somehow. But I'm not worried about that. I mean, I trust humans because in the end, if the things you generate are really bad and boring, people will just stop listening to them. So I don't think there is a big danger. But it's true that there is a kind of strange loop in there, of course. But as soon as you do machine learning, you have this kind of problem. I mean, I guess.
Okay, so thank you for the question. I think we're going to have a last. I'm going to have a very quick fire question. We've got only 2 minutes, so we'll do a very quick wrap-up question. Who have we got for questions? We'll do this one over here, because you've got the mic. And then we'll go
I am holding the conch, but that could change. Okay, so hi, I'm Mark Gotham, King's College London, and I was interested in François and several other people talking about different kinds of musical data. In my case, I responded particularly to François talking about a single song and all of the different knowledge that's embedded there. So as somebody who's worked on what you might think of as quite simple kinds of musical data, but nonetheless complicated enough for machine learning to have a leverage. So for example, harmonic analysis on symbolic music, and we've seen how that rapidly improves and outperforms deterministic algorithms, and is a kind of musical knowledge that we can get some kind of traction on with machine learning systems. I wonder if we have time for you to talk a bit more about other kinds of musical knowledge of that sort, whether you think it is something we can get machine learning traction on or not, and perhaps even a N years prediction for how future-proofed work in that space would be. So should we sink the next 5 years of our research agenda into encoding that kind of knowledge, or is it going to be blown out of the water? I think that might be more than a 2-minute answer.
That's a lot of questions, yeah. So
Thank you.
I will maybe just ask two of the panelists to respond very quickly, maybe 1 minute each. So who would like to jump in about this? François?
Maybe
or
it was
Rebecca?
more for François, no?
Let Francois go first.
Are you sure?
Yeah, quickly.
Maybe quickly, François, quickly.
Quickly, no. So I don't know what you should do. I mean, I don't want to set up research agendas, but I think it's a very interesting problem if you take one song or one item and try to have an AI that tells you what is really special or unique or singular about this item as compared to a huge data set, for instance, or another data set. Try to singularize, or I don't know what is the word, but explain me why this song or why this thing is really new or different, or explain to me why it is not. And that would be a very useful tool if we had that. Each time we do something, the system would tell you, hey, what you've just done has been done 2 million times, or hey, this thing has never been done, or has been done only in this context or that context. That would be very useful. So yes, going back, doing a bit like the opposite of generalization, singularization would be, I think, a very useful tool.
Becca, you got anything quick?
Sure. I guess I would push back on and maybe expand the question a little bit. We'll leave it there. And I think, so much of what I see that I might critique in the mainstream media-driven narratives around machine learning and music right now, it's there's this focus on systems that are trained on really, really big data sets by really big companies with a lot of resources, and it's kind of clear. It's like, okay, there's some conceptually cool stuff here that we can type in a text prompt and hey, it sounds like real electronica or something. And that is absolutely impressive, and I'm impressed by how quickly we've gotten to that point. But at the same time, there's not necessarily always a deep motivation in terms of people thinking, oh, what is beneficial to people in a particular community? I think the use cases for that kind of system, probably some of them are out there, but I have big question marks about it. And I think, this question of, what are the problems where we can gain traction? I think that's one really interesting question to ask, and I think it's worth asking that in different disciplinary contexts. If you're a music theorist, or you're trying to build systems that have some underlying reasonable conception of musical harmony rules, then that it is absolutely the right question to say, yeah, with what data and what kinds of models can we make progress to make these tools better for these particular uses, or to understand things about music theory that we haven't before. But I think also, what I would throw into the mix here is, there are all sorts of other questions that might arise from other communities, some of which, many of our experiences here on the panel coming from musicians themselves, saying not, where's the traction, but hey, what are the musical uses? What's the utility? What are the affordances of these tools that are arising, and how do we exploit those? But also, how do we see where the gaps are and see how we might make things better? And that's one of my motivations for being in this project. But I think there are absolutely other communities as well represented by, for instance, people who've spoken in the case studies this morning, and we'll be hearing from them this afternoon.
Yeah, thank you. Okay, so we come to the end of the panel. We'll have to save the other questions. You can ask them over lunch. I'm going to have a very quick question to each panelist, just to sum up with a 30-second answer or something like this would be perfect. So, we've all talked about how difficult it is to use these small data sets or these machine learning pipelines. So my question is, why bother? Why are you doing it? And how could we actually make these machine learning pipelines more open to musicians and artists to use, right? So I'm going to go this way around. So, Phoenix first, 30 seconds. Why bother, and how can we make it more open?
Okay, why bother? Because these data sets are being used and collected about you, whether you like it or not. And your understanding of them and harnessing them almost in a subversive way for yourself is actually really revelatory right now.
Thank you. No, why bother? How could we make it more open?
I mean, the potential of facilitating expression and creativity is huge, but also there's quite a lot of risks involved that we as creators have kind of the duty or the responsibility to avoid and point in the right direction. So I think, you know, we're as academics, as creators, as researchers, we're in a crossroads, and I think it's a very important to collect, to scan, to map the terrain, and to advance this field further.
Okay. And François, why did you do this, and how could we make it more open?
Yeah, so in the field of music generation, big or huge data sets just don't make sense. You know, you can't make sense of them. You don't know what they are, what they mean. So you do small because you can't do big. I mean, you can't describe. You can't really understand when it works, when it does not. You don't know why. So I think it's the question should be the other one. Like, why do you want to use huge data sets? I mean, technically we know why, but conceptually there is no reason.
Okay,
Yeah.
thank you. And Rebecca?
I like that answer a lot.
Yeah.
I would also add, again, you know, the question should come back to why are we using machine learning? What is machine learning good for? And thinking about, you know, machine learning as a set of tools for really just capturing patterns in data and making predictions about those patterns, or generating content with similar patterns. Like, there's nothing about that inherently has to be about big data sets. I would hope that people's answers for why machine learning is useful go beyond, well, you know, I had a data set here, it was convenient, and hey, there's something cool. I think we have other use cases that are more interesting, and often the answer about, you know, what data set is the right one for that use case, often it is data sets that are smaller, that are curated, that are representative of the things that somebody really cares about.
Great, thank you very much. And so I'm going to finish the panel there. So I'd like to thank all the panelists. Thank you very much. And a wonderful discussion. Now we have lunch, I believe, out in the kitchen. We will start the next case.